This question is 1-bit and 2-bit characters. So you're going to have two special characters, and I'm going to explain this later. So you're given a binary array bits. So let n with 0. So this is the case. Let n with 0. So you want to return true if the last character must be a 1-bit character. So what does this mean? So let's look at this. We already know like you are given the array, right? But I don't care like what's inside the array because I know at least all I know is the last bit has to be 0, right? And whatever value you have in between, right? It doesn't matter if it's 1 0 1 1 1 or 0 1 or 1 1, something like this, right? It doesn't matter. You want to make sure your last bit has to be a 1-bit character. So think about this. What you can do is your first character can be what? A bit 0, right? And then your second character can be what? 1 0 or 1 1. So if you look at this, the example 1. So we already know we don't care about last character. And then let's look at this. If this is 0 and if this is 1, can I form the character 1 0 over here? So this can be, something x, right? And I already know this is what? A special character that is n with 1 bit, right? So this is what you want to return true. But how about this? You don't care about this, but because you know it, right? All right, you have 1, and you have 1. And you can form this together for the second character. But you still need a extra value, right? An extra value from 1. So this is why you return false. But how about this? 1 1 1 1 0. Again, what you can do is what? You can form this 2 1 and this 2 1 together for the a special character that is what 1 bit. So this is the case you return true, right? Because you can form, right? So how about this? 1 1 1 0 0. So again, you don't care about the last value. 1 0 you can form as a second character, right? This is 1 0, and this is 1 1. Like when you are able to form a character that is possible, right? So what you can do is you want to traverse all the way from the the back to the beginning, and then count the number of 1 when this is subsequence. So imagine you have 0 0 0 in here and then 1 1 0. So imagine you have this. It lists the it lists the 1 bit. I mean, are you going to return true or return false? So let's do this. So you end with 0, right? Doesn't matter. So this is what? This is 1 1, right? 1 1, that is a special character. And 0 0 doesn't matter. And then you have 1 0, right? You can form this as a special character, right? You are not allowed to have 1 by itself. So in this case, you will return true. It's not possible to return false, right? So you can just see if you have a 0 in between 1, you can actually skip. You don't need to traverse this. You only need to traverse everything, every single one after the first bit. So when I say the first bit, it's going to be the last bit. So let's see. So what you can do is int 1 equal to 0. For int I equal to bit.length minus 2. I equal to 0 and I minus. And then you want to traverse only if the bits are equal to 1, right? And then you increment the ones, right? And then what you can do is want to make sure the 1 multiplied by 2, which is divided by 2, the remainder is equal to 0. And submit. Alright. So here's the problem, right? Minus 2 bit that. Okay, here's the problem. Are we going to have the bit that are equal to 1 in the if statement? Probably not. We need to make sure we have this, right? We have this. So I put a condition in here. And then let me run it again. So that is a small, thing that you want to make sure. You want to make sure the current bit is actually equal to 1, right? And then you don't want to traverse this scenario. Let me see. 0, 1, 0, 0, 1. You don't want to traverse this scenario, right? When you actually hit a 0, you want to break. You want to break it out, right? This is the excess, right? When it comes here, it's good. When it comes here, you want to break out a full loop, right? And then you return if 1 small by 2 is equal to 0. So this solution I made on purpose is you want to keep traversing until the first bit, which is index 0. And then it's not the case. So if I believe there's a way to work around. Oh, else break. If you want to code like this, it's fine, but I don't recommend you doing this. So yeah, this is another approach. So time and space is constant, times all of n. So this will be the solution. This is also part of greedy solution. So let me know if you have question, and I'll see you later. Bye.